Welcome to the Glacial Gold Hunter, Northern Minnesota edition. So we're up in the part of Minnesota that's known for its iron mining, but it soon might be known for its gold mining. You see, years ago the DNR was doing surveys of the glacial till in the area, and what they found is that there's some locations where there's a higher count of gold specks in the glacial till. This led them to believe that there might be a lode gold deposit nearby. They haven't found it yet, but maybe today we did. Alright, so I'm here with Diane and Don, and they were kind enough to let me come on their property where there's a potential lode gold deposit. They've got a quartz vein here that they stumbled on, and how did you guys find this quartz vein to begin with?
The way I heard about it was my grandson was about 6 years old or 7 years old, and he came up here and he's tramping in the woods, and he comes back with a big piece of quartz, and he's like, "Grandma, you got quartz back there." Well, of course, Don knew about it because he grew up on his property.
Right, and like I say, we considered it, I don't know where the term money rock came from, but maybe that's because it was known to have gold in it at some point or something.
Quartz is a money rock.
Right, so yeah, I guess I never put much thought into it in the last 50 years or 60 years, you know. I lived here my whole life, like I say. But so it's just interesting to know if there's anything really actually in it, you know, or not.
Yeah, leave it to a kid to find a gold deposit, you know, that's how that works.
And the reason why I contacted you is because you had mentioned you wanted to come to northern Minnesota and look for quartz.
Yep.
And just the week before, my girlfriend, who loves rocks, started pulling the moss away, and it was getting bigger and bigger. I'm like, this is a job for Lucas.
There you go. That's why the Glacial Gold Hunter's here. So what I'm going to do is we're going to show you the quartz vein, and I'm going to excavate it a little bit and try to see if there's any gold here. So we'll get started on that. So Jack came to visit too, and he's actually a geologist who's worked in the mines up in the area here, and he's going to help me examine this quartz vein. And what we're going to do is we're going to just take some of the moss back, peel that back, and hopefully find the contact of where the quartz is meeting the country rock, and that should be able to tell us a little bit more about what we got here. So here we found the contact between the quartz vein and the country rock here, and it looks to be like this is structure. So the vein extends this way and that way, and that would be a sign that there's a fracture or a fault here. When I look at the country rock on the footwall here, it looks like it was bleached. So what I'm thinking, the way this was deposited up here in northern Minnesota, there were different mountain building events. This would have formed during the Kenoran orogeny. Orogeny is just a fancy word for mountain building. In Canada it's called the Kenoran orogeny. In Minnesota and the States we call it the Algoman orogeny. Same thing. But back in early Precambrian times there was a lot of volcanism. Earth's history is very volcanic, and the Precambrian, very violent volcanic events. So there was a lot of volcanic deposits laid down. Then you had continents colliding with another, and that caused the mountain building events. Those mountain building events metamorphosed all the volcanic rocks, and that would have been a time when the quartz veins would have been depositing as well. Because when you have those continental collisions and all that stress, it produces a lot of heat. That can cause hydrothermal fluids, which then find those channelways in the faults and fractures, and you'll get these quartz veins deposited like so. This is a little dirty, so let me clean it off a little bit more, and then I'll show you a closer look at it. Yeah, perfect. So you can see the beautiful quartz right there coming in contact with the footwall. And you see how white that is. That can be hydrothermal bleaching. So as the fluids are flowing through, it can also bleach and alter the footwall here. And this can be a form, you see how like this is prominent and it's prominent over here, and there's been a lot of erosion right there. That's because at the points of contact, you can have a lot of alteration of the minerals, and that'll form clays that will weather away a lot easier than the solid rock. So at points of contact of the fault or at these veins, you can have a lot of softer material that erodes away. That's why quartz veins oftentimes stick a little bit more proud than the rest of the rock. But here in glacial country, everything was kind of buzzed flat anyway, so you don't always get that proud, prominent look of a quartz vein. So Jack just uncovered this. He kind of rolled this vegetation back like a carpet, and this shows the contacts really well. This is really cool. So you can see this quartz vein is kind of, it's a little fractured here too, because you can see there's a big fracture in the quartz. So there was still things going on after the quartz was deposited. But here's this boundary, the quartz and that country wall or country rock right there. And here's even a piece of the country rock embedded in the quartz. So this would have been a piece that broke off and then got surrounded by that hydrothermal fluid and then locked in place forever. Now that it's cleaned off here, you can really see that contact.
So the fact that this lies in here on this joint, and then the joint goes through the quartz also.
You can see on the footwall this displacement of the vein comes all the way down on the hanging wall here. So this is a little fault that happened. So cross-cutting relations, you had fault of your host rock, you had deposition of the quartz vein, and then another fault going in like that. So you can tell the order of which things happen. So we've uncovered the vein from here, and it extends all the way beyond there. So it's a significant vein. Like there's more than just a nodule of quartz here. This is on a structure. So I think the next thing we have to do is take some samples and then see if there's any gold in it. Remember, always wear your goggles when you're cracking rocks.
Four eyes, you need glasses to see.
So I got a pretty good sample size here, and when I look at it, it doesn't look like there's a lot of mineralization in there. It looks like very pure white quartz. Remember, not every quartz vein will have gold in it. It takes a series of, the right pH, the right pressures, the right temperatures to get that gold dissolved into the hydrothermal fluids and to precipitate at the right points. So we won't know what's in this until we take it home and pan it. If I do find gold in it, then I'll come back and maybe do some assay testing. You gotta pan it out first. Here's another quartz vein in a different area. I just did some roadside geology and went searching for an outcrop and found a quartz vein. I'm gonna take a small sample from here and just compare it, and maybe there's gold in this one. This is right next to Lake Vermilion. Lake Vermilion's just off that way, and that's where the gold rush in the 1860s was here in Minnesota. So I do know some of these quartz veins do have gold. I just don't know which ones. So we'll take a piece here. There we go. That's a nice piece. Now, one option when you're prospecting is to go to a gravel pit. Now, in Minnesota, the gravel came along with the glaciers, so they would have picked up pieces from all over. So when you're looking around at the cobbles and boulders of the gravel pit, you might find a piece of quartz or a mineralized vein that came from far away from here, but it still might have gold in it. And since this is an area where there is known quartz veins with gold, it has a higher potential to hold some of that gold-bearing quartz, or maybe some other cool rocks. Now, some gravel pits are actually flows. It can be flows of eskers or whatnot, so you can actually see stratification in the gravel pits when they dig into them. And that might be a place where there was an ancient riverbed, or, well, if there's stratification, there was an ancient riverbed there, and that might be a place where you could find a concentration of gold. I don't see anything like that at this gravel pit, but there's a lot of cobbles and boulders, so let's look around and see what we see. Now, this rock caught my eye because there's a lot of oxidation on there. A lot of iron staining. It's rust is basically what it is. And when I break it open, it's very black. It's not quartz, but there's a lot of sulfides in there. Sulfides can be a source of gold. However, this looks kind of like galena and iron pyrite or pyrrhotite. I don't know if these would be gold-bearing sulfides, but it might be worth testing. It's a cool rock anyway. So here's a chunk of quartz I found, and it's not that bright white quartz, but it's still a lot of quartz in there. When I break it open, it's got sulfide nodules in there. Now, as I've said before, sulfide can be an indicator that gold is present because when those hydrothermal fluids are collecting the minerals, gold doesn't like to go in that solution unless there's a ligand involved. Sulfur can act as a ligand. So as that's flowing through the fractures or the faults or whatnot, and that sulfur starts to precipitate, it leaves the gold behind. And since gold doesn't want to be in solution, then the gold will start precipitating too. So if this was quartz-bearing material or quartz-bearing solution that had gold with it, and those sulfides precipitated out, then there's a good chance that there's gold precipitating as well. But was there gold present? I don't know. Let's test it. I think you'd be able to see some. Can be really fine though. Now sometimes in these gravel pits you're lucky enough to have water that's deep enough to pan in. When the DNR did their test, they were just sampling the till. Now if there was a good river flowing through, then that would be a way to concentrate that gold into little strings of heavy material. But since around here there aren't really good flowing rivers, they're all kind of just swamp drainage, your ability to find those strings of gold is kind of eliminated. It's just not enough topography after the glaciers went by. But there's all this gravelly till here. Maybe it was deposited by river flow in the past under the glaciers. I'm not sure about this area. What I'm going to do is I'm going to take some of this till and pan it out right here. Maybe there's gold, because you never know if there's gold until you test. Kind of does look like river sand, so maybe there were river streams here. I don't expect a big result here, so I'm going to do several pans back to back right away. And if I do that and there's no gold, then it's probably not worth staying trying to find any. And it's just loaded with pieces of iron formation. A fine layer of black sand. Let me pull this back really carefully and let you know. So there is one incredibly small piece of gold right there. That was 3 pans back to back, and that's what we get. So it's 3 pans back to back. That tiny speck isn't enough to make me stick around panning. However, I think if we found a place where there was actually some river flow, we might be able to find a string of those little tiny specks collected, and that might be worth digging. We just got to find a place where there's flow.
Go with the flow.
Yeah.
Go with the flow.
No, I gotta get out of the flow.
In the meantime, I got an assortment of quartz chunks from here, there, who knows where, and I think that'll be an interesting test to see if there's anything in those. All right, let's go find some flow. So there's a river right here, and I actually do see some gravel on the riverbed, so there's a chance that maybe there's some heavy material dropping off there mixed with some gold. It's like a good sandy gravel mix. There's a little bit of black sand there. A little bit of lead, but no gold. But the fact that there's gravel here kind of has potential, so I'm going to poke around a few more spots and I'll let you know if there's anything. Well, I didn't discover any gold, but I did discover some more holes in my waders. Womp womp. Here's another gravel pit, and you can see right there is the base of a river that once flowed. And then that's a river channel. I took a few scoops right at the base there, hoping to find some gold. No gold. So now I'm driving down this logging road in the middle of nowhere, and this is right in the heart of where that DNR sample was taken. But I look over and I see that big white piece of quartz. So I'm gonna knock a piece off and test that. Can you imagine mining this stuff?
You already are.
I remember hearing that the reason why the gold rush didn't really take off is because the quartz was so hard. It wasn't economical to spend the time getting the little bit of gold out. Wow. There's definitely some stuff mixed in with that. Interesting. Question is, how much do I take for a sample? That's probably good for a sample. If it's loaded with gold, I'll mark the spot and come back. Okay, we're back at the shop and we got an assortment of different quartz from different quartz veins. I'm going to keep all these samples separate and then pan them out individually so we can try to isolate if one has gold or more gold or less gold than another one. But I'm going to start with the first vein that we looked at. I would love nothing more than to throw this into my propane tank ball mill that I'm building. Got some wheels here, propane tank, and that'll spin like so. Got a variable speed treadmill motor to power it, but it's not done. I'm not an engineer. It takes me a long time to figure stuff out. But in the meantime, I'm just going to use my handheld rock crusher. And yes, I know it's way easier if I heat the quartz up. Don't have time for that now. So I'm just going to work with my muscles. So my crushing system kind of only turns it into gravel at first, but there's a lot of powder in there as well. So I'm going to take my sieve and then sift it out so I get all the fines in one spot. Then I'll try to run through the gravel sized part again, get it a little finer. But with this thing, I'm only able to get it so small. That's why it would be nice to have the ball mill. But we should be able to get a good test from this. Alright, I certainly didn't pulverize all of that, but I got a few pounds worth here, and I think that's enough for a sample. Now ideally, this will be enough to show if there's any gold at all, any trace. If I can find any trace of gold, then that might warrant going back for an assay, where I can get an actual scientific quantification of how much gold is in that vein. But if I can't see even a trace of gold in here, then it's probably like 90% of the other quartz veins, and there's nothing in it. But that's ready to test. The next sample I'm going to prepare is a vein that was real close to Lake Vermilion itself. Let's see what's in here. Now this is a sample that we found on the side of the logging road, and it's notably different because this one has some obvious sulfide nodules in there. You can see the oxidation, and there's some other things growing in the quartz as well. They kind of have a green texture, or a green color to them. We always talk about sulfur, but another ligand, another thing that helps that gold go into solution is chloride. So you can have chloride-rich quartz veins and sulfide-rich quartz veins, both of which can be associated with a gold-bearing quartz vein. Now, I'm not an economic geologist. Maybe somebody in the comments will correct me, but that's the best of my understanding. Hard rock mining is kind of new to me, so there's a lot I don't know. I'm just giving you my best guess of the information that I've read. Don't take my word for everything, but that's to my best understanding. So this one will be really interesting to see what's in there. So I've got 3 separate samples separated and prepared. Now the only other samples that I have are the ones that I got in the gravel pits. And it's an assortment of all different types of quartz. This one's very dark, very heavily silicified, very hard. I can see oxidation throughout it. This one was hosted by schist. You can see there's a lot of micaceous schist right on the edge there, and a completely different texture. And then there's some other quartz that looks very similar to the samples that we've already prepared. But being that there's such a different array, this might take a little more time to kind of prepare properly and see what I'm doing. And I left the house at 7, it's midnight now. That's exceeding my budget for a YouTube video, time-wise. So I might turn this into a side quest later, and right now, we're just going to deal with the 3 samples I have prepared. So we got our 3 samples here, and when I look at them, the color is a little bit different on the one from Don and Diane's. The other 2 look pretty much the same, but but this one has just a little bit different color. Maybe that's because there's some dirt in it, I don't know. But we're gonna get to panning this. So I've scrubbed out this pan so there won't be any contamination. I'm gonna start with Diane and Don's. I'm gonna pan it because panning, it can be really slow and methodical. It's a really great way to separate the material. I don't see any gold yet, but I see a lot of black sand, and there's some very shiny metallic pieces of metal there. So I'm gonna just take some magnets and see if I can pull the metallics away. But I don't want to pull the gold away either. So I'm gonna kind of wiggle it. So hopefully if there is any gold, that'll kind of get left behind. This might just be from my grinding system. So it does appear that there are some tiny, tiny little specks in there. I can't confirm that they are gold, but they sure do look like gold. It's possible they're sulfides, but it kind of looks like to me like those are some very trace amounts of gold. You can see next to the dime just how small we're talking about. But still pretty cool. So unfortunately with those trace amounts, I don't think we found the mother lode today. Just some exceptionally small traces, which is cool, but nothing profitable. However, let's see if these other quartz veins look any different. So the next one I'm gonna try is the one that we found on the roadside right next to Lake Vermilion. So here's a vein next to Lake Vermilion, and it looks about the same. Very tiny amount of specks. But even though it is such a trace amount, I do think there are more frequent tiny specks in this vein. Still nothing I would think would be profitable. So the last one we have is that big chunk of quartz we found in the logging road, kind of in that zone where the DNR was finding a lot of specks. So this logging road sample does have a different look to it. I do think I see some of those tiny, tiny trace specks of gold, but it's a lot of silvery looking specks, and I kind of think that's galena. There's a lot of sulfides in there, whatever it is. And still a pretty small quantity. Well, so far this hard rock mining doesn't give nearly as much to show as the placer mining, but I know there's quartz veins up there that do have visible gold, so someday we might just run into one. Not today though. I think all the samples we looked at today are just too trace of an amount to consider viable to even test further, but still super cool to see some in-place quartz veining. They just didn't have the right chemistry or conditions for depositing gold, which is most of the quartz veins you find. Big thanks to Don and Diane for letting me come on their property and dig around. That was super fun to see. Thank you, Jack, for the valuable information. He gave me some new prospect locations that might lead to better results. And thank you to all of you for watching. Come on back for the next episode. Bye-bye.